All right, so we have spent a lot of time talking about acids and bases, different ways to indicate or to tell us whether we've got an acid or base. And we spent a little bit of time talking about pH, and pH being how acidic something is. We said if pH is less than 7, it's an acid. If it's greater than 7, it's a base. If it's got a pH right at 7, that would make it neutral or neither. Well, there is in fact a way to solve or to calculate for the pH of a solution given its concentration. And we know we measure concentration using molarity. So let's take a look at how we start to solve that for our different solutions so that we have some way, if given some value or concentration molarity, we can figure out what that pH might be. So the general idea when we start to look at kind of our molarity or concentration and the pH scale is as follows. And pH we know is powers of hydrogen, parez-vous de hydrogen, as the original French would say. Don't quote me on that. I know that's super bad. And there's a way we can get to that using a couple different ways. One would be the pOH. Well, if pH is powers of hydrogen, pOH would be powers of hydroxide, or how basic something is. It's kind of like yin and yang. If pH is one side of the coin, pOH is the other. And there's this funny little thing with brackets and the hydroxide. This just means the concentration of the hydroxide ions, or the hydroxide or base concentration. We also have brackets around our H plus, which would be the concentration of or molarity of the acid. Now H plus, remember that's the same as H3O plus or hydronium ion. That's what's formed when we've got an acid dissolved or dissociated into water. So let's kind of look at this. Let's start to piece together different pieces here so that we can make sense of kind of our general trend. Well, just a couple things to remember that these brackets just indicate the molarity. And so if we've got brackets H plus or brackets H3O plus, that would mean the molarity of the acid. Bracket OH minus means molarity of base. And we know that our pH scale typically will go from 0 to 14, but this isn't absolute. We'll actually come to find that if you have a concentrated acid or concentrated base that is a molarity greater than 1, you can actually go beyond this pH range. But this is in generality where our pH range will fall. And there's more than one way to solve for each of our corners. We can go from H plus clockwise around our kind of box or counterclockwise around our box. So let's take a look. Let's kind of see what we're going on here, what's happening, and see if we can't figure out how to calculate these different ways. Now to calculate your pH, there's two different ways. The first way is to calculate from the concentration, or the bracket H plus. Remember, this is the concentration of our acid. And if we want to know the pH, we're just going to use a logarithm. Whoa, please don't cringe. Don't throw things at the screen. We all maybe have heard of logs before, logs being kind of logarithmic scale or powers of 10. To find pH, we take the negative log of the H plus concentration. And really what this is, as chemists, we're lazy. Oftentimes we'll have very dilute concentrations of acids. And so instead of writing all the zeros, we'll do this kind of negative log to find a pH value. Now what this means is if you have a pH of 3 and a pH of 4, a pH substance, substance that has a pH of 3 is actually 10 times more concentrated in its acid particles than a pH of 4. Likewise, a pH of 4 is 10 times higher concentration than a pH of 5. Now, that's one way we can solve for pH. The other way is from the pOH. Now, a pOH scale doesn't really exist. We always think of pH. But it makes sense. If pH is how acidic something is, pOH is how basic something is. Well, if you add the two together, you have to get the total of the scale. The total of the scale being 14. So pH plus pOH will always equal 14. Thus, if you want to solve for just pH, you would take 14 subtracted by the pOH. So let's kind of see how this would work. Let's do an example problem to see kind of how these start to fit together. So let's say you had a substance that had a concentration of 1.00 times 10 to the negative fourth molar, or concentration. And this is hydrochloric acid, this is an acid, and we want to know the pH. Well, we would merely take the negative log of that concentration, negative log of that value, 1.00 times 10 to the negative fourth, will give you the pH, pH being 4. If a solution had a pOH of 6.25, we want to know what the pH is. Well, pH plus pOH has to equal 14. Therefore, to find the pH, we're going to take the 14 minus pOH, so 14 minus 6.5 gives us 7.75. Well, a pH greater than 7 will be a base. We know that 7 is neutral, higher than 7 makes it a basic solution. Now, water. Oh, water is unique. We know that water is both an acid and a base. Here we've got two water molecules. The first is giving away a proton to form a hydroxide ion. There's our acid, but it becomes a conjugate base. Our other water molecule is acting as a base, accepting that H to form a hydronium ion, very much an acid particle. Now, water is unique because it is said to be both an acid and a base. We say that this is an amphoteric substance. Amphibians live both in water and on land. Amphoteric means it's both an acid and a base. Well, what does that mean then for the hydroxide and the hydronium concentration? Well, what we would say is that they must be in equal concentrations. They must be equal to one another. Well, if the hydroxide and the hydronium ion concentrations are equal, that must mean their pH and their pOH must also be equal. Well, negative log of the H plus would give us, well, negative log of times 10 to the negative 7th, would give us pH 7. Well, if pH plus pOH equals 14, then the pH and pOH for both must be 7. Well, to go backwards, if we were, for example, to know the pH and we wanted to find the H plus concentration, we would merely do the opposite. We're going to take 10 to the power negative pH. This is kind of the opposite of negative logarithm. So we said if we were going from H plus to pH, we took negative log of the concentration. To find the concentration, we do the opposite, 10 to the power negative pH. To calculate your hydroxide concentration, there are two ways to do it. The first would be what's called the Kw, the equilibrium constant of water. Well, now, wait a minute. Let's think about this. pH plus pOH equals 14. And we just found out that to go backwards, to go from the pH back to the concentration, we take 10 to the negative pH. Well, wait. The total of the scale is 14. If you go backwards, 1 times 10 to the negative 14th is what you get when you take 10 to the power negative 14. 10 to the negative 14. So really, this is the same as the other side of our box, going from pH to pOH or pOH to pH. We either add or subtract from 14. Here's that 14 again. And so if we wanted to solve the hydronium concentration or the H plus concentration, we could also use this funny little thing called Kw. So let's look at an example problem. And if you want to pause it and calculate this out while we work, might not be a bad idea. If not, kind of follow along and make sure you're feeling okay on these calculations. So this question says, what is the molarity of a nitric acid solution that has a pH of 3.50? Well, nitric acid is an acid. So if we want the molarity, that means we're solving for the H plus concentration. Well, we know to go from pH to the H plus concentration, we're going to take 10 to the power negative pH. Well, 10, so we'd hit the shift button and then the log function, because this is kind of anti-log, if you will. So we'd do 10 to the power negative 3.50. When we solve for that, we find that the H plus concentration, the molarity, is 0.000316 molar. Now, if we wanted to do this a different way, we could use this thing called Kw. Kw, again, from the slide before, is just this equilibrium constant for water. It is just a constant at a given temperature, and we know it is, again, to the negative 14th, which is, if we were to take the negative log of this value, we'd get 14, pH of 14 when you add the pH plus the pOH. Well, if we were to multiply the hydroxide plus the H plus, we get that Kw. And so if we are looking for one of those values, we would take the Kw, which is just a number, 1 times 10 to the negative 14th, divided by, in this case, the hydroxide concentration to solve directly for the H plus concentration. Now the good news is that you can solve, kind of go around our box in a variety of different ways. Again, this is the same box that we saw before. We can go from H plus to pH, pH to pOH, pOH to OH minus to H plus if we want to go clockwise around the circle. We can also go counterclockwise, and we can solve in any version or any way we want for these. We know to go from H plus to pH. To go from pH to pOH, we know that those two added together must equal 14. Therefore, if we take 14 minus the pOH, we'll get the pH. If we take 14 minus the pH, we get the pOH. So if we want to go from here to here, we're going to use this first formula. If we wanted to go from here back to pH, we would use this formula. We know to go from the H plus concentration to solve for pH, we're going to take the negative log of the hydronium concentration. Will get us pH. To go in reverse, we're going to take 10 to the power negative pH to go back to the H plus concentration. What's nice is this is mirrored on the base side. Sorry, let me get it up here. Notice to go from pOH, from the hydroxide concentration, to go from here to pOH, we just do negative log of the hydroxide concentration. Well, that's just like we saw for the acid part. To go backwards, we do 10 to the power negative pOH. It is exactly the same. It's just on the bottom, we're talking about a base. On the top, we're talking about an acid. And I love it. The far left side is the same for both directions. You would just use whatever you know to solve for what's missing, Kw again being that constant. So using this, and I would really strongly suggest to pause the video and get this in your notes, because if you know, for example, H+, you can solve all the way around to get to the other side. Conversely, to get back to the H+ or the acid concentration. Hope this has been informative. If you've got questions, please do not hesitate to shoot me an email or ask me personally in class. Hope this helps kind of give you an idea how we start to calculate pH and pOH given our different concentrations.